Okay guys, we've been working on chapter R, and today we're going to start chapter 11. In chapter R, all the lessons were like completely different things. Just to review you, chapter 11 now is going to be like a continuous type of lesson, so hopefully stuff starts making more sense and you can put things together day by day. So, sequences and series is the name of the chapter. All right, I'm going to keep this real short and sweet. An infinite sequence is basically a sequence of number that goes forever. 1, 2, 3, 4, 5, ... 2, 4, 6, 8, 10, ... A finite one is one that actually stops. 2, 4, 6, 8, 10, 12, and that's the end. 1, 2, 3, 4, 5, that's the end. So infinite goes forever, finite stops, just like you would expect. Just an example of a sequence says suppose that $1,000 is invested at 6% compounded annually. The amounts to which the account will grow after 1 year, 2, 3, and 4 years, and so on, form the following sequence. I want you to learn one thing from this slide. The first term is going to be known as A1, the second term, A2, the third term, A3, the fourth term, A4, and so on and so on. We're going to be looking for patterns between terms today, and so you need to be noticing stuff like that. Like this time, they're multiplying every time by 1.06. That's the pattern, 1.06, 1.06. So make sure you know the names of the terms, and also we're going to be looking for patterns between the terms today. All right, this one says find the first 4 terms and the 23rd term of the sequence is general term. When they say general term, they're talking about AN, like the equation, AN equals whatever. So to find the first term, all I'm going to do is I'm going to plug a 1 in everywhere I see an N. So it's going to be -1 to the first power, 1 squared. I just plugged it in right there. Work that out, you will get -1. To find A2, or the second term, I'm going to plug a 2 everywhere I see an N. I'm going to plug one there, and work it out, and we get 4. Third term, just plug in 3 everywhere. -1 to the third, 3 squared, you get -9. And the fourth term would be -1 to the fourth. Again, I'm just plugging the numbers in. 4 squared, that would be 16. But it also said this, it also said find the 23rd. You can find the 23rd also, just -1 to the 23rd power, and then 23 squared. I'm going to punch in 23 squared into my calculator because I'm not exactly sure. I think it's 569. Let me see. 23 squared. 529, that's close. And it's going to be -529 because anytime you raise a negative number to an odd power, stays negative. So -529. All right, use the graphing calculator to find the first 5 terms. That's not really great to do on a video. I'm going to show you that in class tomorrow, step by step, how we can do that on the calculator to find the first 5 terms. Not hard at all. For each of the following sequences, predict the general term. So they're wanting you to write, kind of what the general term. Remember, the general term is AN, or the nth term. So I'm going to say the nth term is, look what's happening here. It goes 1, square root of 2, square root of 3, 2. What those are square roots, like square root of 1, square root of 2, square root of 3. Square root of 4 is 2. So that's just this. It's just square root of n. Part B, look at that one real quick. It's actually, it's really like 3 to the 0 power, 3 to the first power, 3 to the second. It's just all 3s. So I'm going to say, okay, it's going to be 3 to the, I would say n power, but if I plug in 1 in for n, I don't get -1 for my first term. I need to have a 0 power. So I'm going to do this. I'm going to put n minus 1 power because that would give me 3 to the 0 where I needed it, 1 minus 1. If I plug in 2, it'd give me 1, which would be 3, which is good. Now, here's a little trick. Every time the signs are changing, you need to do this. You need to put a -1, and to make the sign change, like it starts negative, so I want the first term to be negative. So I'm going to put an n here, and if I plug a 1 in right there, which stands for the first term, it's going to be a -1 times 1, which is good. The second term will be positive because the even terms are positive, so I need the even ones to be positive, so that works out really well. Let's try C. All right, on C, that's like 2 to the first power, 2 squared, 2 cubed. It's just the powers of 2. So I'm just going to write 2 to the n power, and that pretty much solves it really good. The nth term, there's not really great strategies for these. You got to find the pattern and find some way to write that pattern as an equation, as a sequence. We'll work on that tomorrow. I keep getting text for some reason. Okay, the sum of the terms series are just when you add the terms all together. The sum of the terms of that sequence would be just add the terms. If it's infinite, still the same deal. We're going to add infinite, which is crazy, but sometimes you can actually do that. A partial sum is when you add up and just, you stop. You don't add every single, you don't go for infinity. A partial sum is also called a finite or nth partials. Tons of names, and I hope you don't see all those words. But a partial sum means you're going to add some of the terms, not every single one of them. And a finite series means sums, means you add them up. A sequence is just a list of numbers. Series, you add the numbers together. Okay, for the sequence, it says this. It says find S1, which means the sum of the first term. Well, the first term is -2. That's it. You can't really add that to anything. Part B says sum of the first 4. So I'm going to take the first 4 terms like this and add them together. And when I do that, it looks like I'm going to get 4. And part C says find the sum of the first sum, or the fifth partial sum. That's another way you could say that, fifth partial sum. Now, the fifth partial sum is just taking the first 4 and adding the fifth number. I just added the first 4, and I got 4, so I'm just going to say 4 and -10. That's -6. So when you see an S with a subscript, that's a sum, and the subscript tells you how many terms to add together. Sigma notation, this is what sigma looks like. That's big sigma. Sigma means sum. Another word for sigma notation is summation notation. Just remember, if you see sigma, it means sum. Add them up. Okay, I'm going to show you how sigma works right here. Look at this one. Notice there's a number below the sigma and a number above the sigma, and then there's this k cubed right there. All you do is this. You take the 1, the number on the bottom, and you plug it in for k. So I get 1 cubed. Then you take the next number up, 2 cubed. You take the next number up, 3. I'm just plugging numbers into k until I get to the 5. When I get to the 5, because it's on the top, that's where you stop. When you get to the top, that's where you stop. Kind of rhymes. Okay, so now you just add them up. So 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed. Add all those numbers together. Wow, let me punch my calculator real quick. And you would get 225. My phone is going crazy. 225. So, but that's how it works. Hopefully not that big a deal. Let's skip over to this last one over here to C, because it looks like it may be a little more difficult because it's got this fraction thing going on. So again, I'm going to start with the 8 and plug it in for the I. So it's going to be 2 plus 1/8. That's the first term. Plus, now I'm going to plug in a 9. 2 plus 1/9. Plus 2 plus 1/10. Plus 2 plus 1/11. I'm going to stop on the 11 again. The reason I'm stopping on the 11 is because it's the top number. Every time you get to the top number, make sure that you stop. I can add the 2's very easily. That's 4 2's, that's 8. I'll probably take these fractions, just punch them in my calculator and add them up. And I'm doing that, and golly, this is what I'm getting, 1691 over 3960. All right, now they're going to make you go backwards. They're going to give you a sum and make you write the sigma. So I'm going to go like this. It's kind of like the general rule again. This is going 1, 2, 4, 8, 16. So those are powers of 2 again. 2 to the 0 power, 2 to the first power, 2 squared, 2 cubed. So I'm going to go 2 to the n power. Here's a trick I'm going to do though. On the bottom, I can put whatever number on the bottom I want to that will make this work. So what I'm going to do is I'm going to say 0 power because I need it to start with 1. So if I do that, that means this is the 0 term, first term, second, third, fourth, fifth, sixth term. So on the top, I'm going to put a 6, and that should work. And just to double check, just plug in a number, make sure you get that term, and it should work for you. All right, let's go to B, part B. Let me erase that one. All right, part B. That looks like it's also, they're doing 2 times things. They're doing like 2 times 1, 2 times 2, 2 times 3. So I'm going to put 2n. N is 1. Let's see here. Yeah, but they're changing signs again. Remember the trick I showed you for changing signs? I'm going to put a -1 to help me change the sign. The first term is negative, so I want the first term right here to be 1 because -1 to the first power is negative. So down here I can go ahead and put n as 1 because if I plug 1 in right there, That would give me 2 times 1, which is 2, times -1, which is good. And there are 5 terms there, so I'm going to put a 5 on the top. I'm going to check the second one real quick. If I plug in 2 for the ends, I would get 2 times 2, and I would get -1 squared. And if you work that out, sure enough, you will get the 4. So that's perfect. That works great. Let's go ahead and hit C real quick. Just one more. You can at least do this, at least draw the sigma. Now this one's going forever, which means my top is going to have infinity. Got that much. What's happening is this. What I'm noticing when I look at these terms, the exponent is the same as the denominator. X squared over 2, x cubed over 3, x to the 4th over 4. They're all the same. So what I'm going to do is I'm going to say, okay, I'm going to get x to the n power over n because they're the same. They're the same. So on the bottom, I'm going to put n equals 1 because that gives me the first term. If you plug in 2, it would be x squared over 2. It looks really good. And we'll work on this some more tomorrow. And the last thing we're doing today is called recursive. And recursive is just means that you have to get the next term, you have to know the term before it, before you can get there. So you have to know the term right before the 4th term to get the 5th term. I said that backwards. To get the 2nd term, you got to know the 1st term. To get the 4th term, you got to know the 3rd term. You got to build all the way up to go recursive. Recursive, they build on each other. Here we go. So it says find the first 5 terms. I'm going to tell you a couple ways to do this. The way I like to think of it is this. First of all, I know the first term, which is really good. Just got to find 5 of them. There's the first one. So 1 down. When you see this right here, the a m plus 1, I want you to think of that meaning the next term. The next term. And when you see this, only when it's written in recursive, I want you to think that's the previous term. So the way I would read this whole sentence right here is I would say the next term is 2 times the previous term minus 3. So if I come down here and want to find A2, I'm going to use this. I'm going to say 2 times the previous term, which was 5, minus 3. That would give me 7. If I'm going to find A3, I'm going to do 2 times the previous term, which was 7, minus 3. That would give me 11. To find the 4th term, I would do 2 times the previous term, minus 3, which is 19. And to find the 5th term, which is the last one, 2 times the previous term, minus 3, and I would get 35. So I will show you one more way in class tomorrow if you didn't like that way, but that's the best way. I'm telling you, I'm just being honest with you. That's the best way. Whenever you see this, think the next term is, and when you see this, I want you to think the previous term. So the next term is 2 times the previous term minus 3. Okay, that's enough, believe me, for today. We will work on this tomorrow, I promise you. Maybe even, if we need to take 2 days, we'll take 2 days, whatever, but I want to make sure you get it. And I know it's all new, but we'll be fine. You'll be fine. Look forward to seeing you tomorrow. Bye.